In this video, we're going to focus on how the spread of action potentials through the heart can create two synchronous contractions. Let's start with a basic review of how cardiac muscle contracts. Cardiac muscle is different than skeletal muscle because you don't need a neuron going to each individual muscle fiber. Instead, you just need to initiate a depolarization in one cell and it will spread to the rest of them, kind of like dominoes falling over. Once the cells are depolarized, they contract. After depolarization and the subsequent contraction, the cells will need to reset. It's like dominoes again, but instead of falling down, they're getting pushed back up. The cells are now repolarized and ready to receive another action potential. Let's zoom out a bit. First, we're just going to review heart contraction. Then we'll replay it and add the depolarization waves that are causing those contractions. After blood has passively filled most of the ventricles, both atria will simultaneously contract, pushing blood down to top off the ventricles. Then it's the ventricles' turn to contract, forcing blood out of the heart. As the ventricles relax, passive filling can begin again. Okay, let's watch that again, but this time, we're going to follow the depolarization waves that are causing the contractions. The depolarization begins in the sinoatrial node, also known as the SA node. This initiates a wave of depolarization that spreads through the atria. This is the beginning of a domino effect throughout the heart. Even though the atria and the ventricles are attached, there is an isolating barrier between them. This creates a wall that prevents electrical signals from passing, except through a single conduction point. This point is the atrioventricular node, or the AV node. The AV node is really slow to depolarize. This gives the depolarized atria time to contract before the signal gets to the ventricles. Once the AV node finally depolarizes, the wave travels down a bundle of conductive fibers called the atrioventricular bundle, or the bundle of His. From there, the signal will split and follow a few different paths down the interventricular septum. These paths are called the bundle branches. When it reaches the apex of the heart, the depolarization wave will turn and come up the sides of the ventricles through Purkinje fibers. Now that the ventricles are depolarized, contraction can begin, forcing blood out of the heart. After they're done squeezing, the cells repolarize, allowing them to relax, reset, and prepare for the next depolarization wave.